So let's look at the third unit inside the CEH certification. So for this we'll have a look at footprinting and scanning. So the main parts which are covered in this unit are the 7-step information gathering process. We'll look at some footprinting for determining the network range, identifying active machines, looking for open ports, some passive fingerprinting, onto active, and then having a look at Nmap. Okay, so what is the 7-step information gathering phases? So for a pen tester, we probably go through each of these stages, going from passive information gathering to more active ones. So the first stage is just basic passive information gathering, on to determining the range of the network, where our devices actually are, then on to identifying the machines which are active inside those networks. Then on each machine we look specifically at the open ports and possibly on wireless access points. We would then look at fingerprinting the operating system, on to fingerprinting the services which are running on the system, and then finally we would write the whole thing up as a report where we would map the network infrastructure. Okay, so the first part possibly involves some sort of passive information gathering. So for this we initially prepared the documentation. So this could be a spreadsheet which had all the main details which were to be collected, such as domain names, IP addresses, DNS servers, basic employee information, what ports are likely to be open, banner details, and so on. Then a useful source of information is on the organisational website. So often a pen tester can determine things like the main information from the news on the system, such as new appointments. It typically shows employee names, which departments they work for, and so on. Along with this, company directories can actually give a great deal of information, especially about finding out key employees, such as the contact from the IT unit. Along with this, the pen tester might look in job boards, and typically they will be picking off the key skills that are possibly required within the company, such as MS SQL, Oracle, intrusion detection systems, Cisco, Juniper, and so on. There's a great deal of information that can be taken from Google, and it's known often as Google hacking, but it's basically just advanced search techniques. So for example, we can search for certain file types in URLs, for certain links, and in the title of the documents. So for example, let's give this a try. So let's say we wanted to look for company returns as a spreadsheet, and we can see here that Google will actually show us the spreadsheets that are related to our search. Okay, so we can also get information from in the US from the Edgar database, which will give us information about publicly trading companies. Then we can look at the alternative sites, such as the SUCS sites, which will give information typically from disgruntled employees or ex-employees about some insider things of the company. Along with this, we can use the publicly available registries, such as for ICANN, which will allow us to determine the IP addresses that have been publicly allocated. Then we can look at the regional internet registries, such as ARIN for North and South America, APNIC for Asian Pacific, LACNIC, which is Latin American, Caribbean, and then we can have ARFRENIC, which is for Africa. And we also have ripe in Europe. Okay, so here's a graphic that shows the coverage of these regional internet registries. So we see the African one here. Europe covers, the European one, ripe, covers a large area. And then we have APNIC, ARIN and LAPNIC. Okay, so most of the information is available through a whois type lookup. So if we just look up, say cisco.com, we see here it gives us information on the administrative support and where the company is registered and so on. So we can also get information from insecure applications. So there's a number of these that are available, and often they release too much information. There is also the possibility of using Usenet, which is an infrastructure with thousands of forums on it, and we can gain information from there too. Another place that we can find information is from DNS enumeration. So for this, and Truther might target a zone transfer, and a key part of this is the SOA record. If the secondary can request the SOA record from the primary DNS server for the zone, and the primary checks the secondary servers and makes sure that it's requesting, the one that's requesting is a valid one, and then it sends it on. The secondary then checks it against its own SOA record, and if it matches, it stops there. If the SOA has a higher number, then the secondary will update it. But then the secondary can then initiate a name server transfer, where it sends an all zones transfer request to the primary server, and then the primary server sends the complete zone file back to the secondary name server. Domain name infrastructure is based around the root, and then we have certain domains below that, such as com, gov, org, and so on. And then we map onto this infrastructure. So we might take a very simple example. And we can see here that this is the IP address, the primary IP address of the site, and then we have certain aliases associated with that. The DNS record itself looks a little bit like this. So you can see this is for noname.com, and this is the SOA record. So the key thing here is that we have a serial number. As we've seen, this is important for domain updates. We then have a refresh time for this, a basic retry for this, an expiry, and then the minimum TTL. So the minimum TTL will define the amount of time that an intruder could take over a domain. So this record here defines the main mail server. This defines the priority of the mail server itself. This defines the main name server for the domain, and this defines the IP address that's associated with the main domain. Then from here, okay, so there we have it here. So from here we can then map the computers within inside our zone. So in this case, Fred is mapped with 10.0.0.2. www is mapped onto the main domain, as is FTP and SMTP. So we can use the NSLOOKUP command to be able to get information from the system. So let's have a look at that. So let's look at the SOA record. And we can see here, this is the SOA record. It has a certain serial number, refresh time, and a default TTL of 1 hour. So this is the amount of time that the domain name will stay valid before it needs to be updated. We can also do the same for the mail record. And we can see here, this is the main mail server that we have. The value that we have here defines the priority. The lower the value here, the higher the priority. So a value of 10 is lower than 20, so this one has a higher priority. Then we can define name servers and so on. So the TTL defines the amount of time that a DNS poisoning could last. Another tool that we can use is dig for Linux and Windows to be able to investigate DNS systems. There's a number of tools that we can use to be able to trace a route. We can have traceRT, neotrace, trout, visual route, and so on. So this shows an example of visual route, visual trace, and we can see here this shows the route from 2 places. The traceRoute command allows us to look at the route that is taken between a source and a destination, and it gives us the basic timings in between and the IP addresses. So after this, the pen tester might want to then identify the active machines. So now that we've discovered the range of the network, we can now identify the active machines on it. So for this, we often use ICMP, such as with ping, to be able to ping a wide range of computers on a network. So permissions should always be sought before this type of test is actually done, because it can look malicious. So the ping goes out and then pings each of the machines on the network to see if they're alive or not. Often though, ICMP is blocked on the network, so this might have to be done with inside the network itself. So we can use a wide range of tools for this, such as Angry IP scan. So we can see in this case it has identified a number of machines that are active on the network. Here they are. And it gives us some idea of the basic performance, the latency to reach them, and we'll also identify the host name if it has one. We can have Pinger, WS Ping, ProPack, Network Scan Tools, SuperScan, and Nmap. So we can see here's an example of Nmap. If we just give it without any options, we can scan a certain network range. So in this case, the 24 identifies 8 plus 8 plus 8 is the network part, so it will scan everything on that network. And we can see here it's found one host. There's its MAC address, and it tells us which ports it actually has open and what the latency was in reaching it. So after the machines have been discovered, it's then possible for the pen tester to be able to find open ports and access points which are also open. So for this, we typically use tools which will then scan the host for a range of open TCP and UDP ports. So we can tell the ports that we have open by using the netstat-a command. So we can see here there's the ports that are actually open on this machine, because they will be in a listening state. Okay, so a connection is typically made with the SYN flag, which is sent first from the client to the server. The server then sends back a SYNAC, and then at the end we get an ACK at the end of it. So this here shows an example of one of the tools in MAP doing a SYN flood. So it is sending in SYN flags onto the machine without actually acknowledging the connection. So there's a number of different modes that we can do to scan for open ports. So the most common is the connect scan. So for this, the client sends a SYN and then waits for a SYNAC to come back. And then the client responds with an ACK and confirms the connection, after which it sends a FINAC. So this is just the same as a connection, as a normal connection would be created. If the ports are open, it sends back a SYNAC. If there's a closed port, it will send back a reset ACK. So whatever is received here will actually receive that. Another method that can be used by Nmap and other tools is a SYN scan. With this, a SYN is sent in and the scanner detects again whether it's a SYNAC or a reset ACK. After this, the scanner doesn't actually send back any flag, so the connection might actually stay open, and it might actually cause a loss of performance on the server because it's got to try and remember all the connections. Often though, the firewall blocks incoming SYNs or could not allow the connection to happen. Especially for a SYN scan, a stateful firewall will detect that the scanner isn't responding back with the right flags, so will disable the connection to the server. So for this, we can also get a FIN scan, and a FIN flag will often get over the firewall in a way that a SYN won't. For this one, what we should see is that a close port responds back when we send a FIN, responds back with a reset. If the port is open, then nothing comes back. So again, the scanner can determine if the port is open or not. Again, we can also get a null scan, which has no flags actually set. Stateful firewall can normally detect this as looking very strange because the connection hasn't been made. We have a Christmas scan, which has FIN, urgent and push, and again the scanner looks for the flags that are actually responding back. And then we can get an ACK scan, which is often used to determine the ACLs on a firewall, or if stateless inspection is actually used. In this case, an ICMP destination unreachable is returned if the port is filtered on the firewall. So it means that the server is being filtered by something like a PIX or an ASA type firewall, which is stateful. If we get a destination unreachable for our ACK scan, then we know that the actual firewall is stateful. So nmap -s gives us a SYN scan, -t gives us a connect, and -sa gives us an ACK. We can do a UDP scan with -su. annuls, scan, fin and Christmas key scans and so on. Okay, so the basic objective is to really scan for a range of ports. Some other tools are ScanRand, which is a stateless scanning tool, SuperScan, which will do a port scanner but also banner grabbing and so on. And we have also the concept of port knocking, where a certain agreed protocol of connections, such as connection on port 50 followed by port 80, will then open up the port. So in this way there is no direct connection onto the server port, but only an agreed way to connect to it will actually open it up. Along with this, we might look for access points and modems. So we can have ward dialers which randomly dials modems, so waiting for a tone for a connection, such as tone lock, phone sweep and THC scan. And then for access points, we have tools such as Kismet, NetStumbler, AirSnort and AirSnare, which are known as ward driving tools, which look able to connect into access points and actually find their details. So the next part of the process, now that we've actually discovered the hosts on the network, we've then discovered the ports that are open, we can go ahead and discover the operating system which is used. So the pen tester could use active fingerprinting techniques, such as a fin probe. Windows responds with a reset flag when we send in a fin TCP segment, whereas the other operating systems typically do not respond. We can have a bogus flag, so we can set out one of the flags with a SYN, and Linux will respond back with the same flag in the response. We can have an initial sequence number sampling. Windows does not have a random value for this, and it doesn't change that much. And various different versions of Linux have different characteristics for the ISM. For the initial window size that we can create, again, Windows and Linux varies with this. We can have an ACK value because different operating systems respond back differently for this. The IP type of service, various types of operating systems either support this or not, and this is related to quality service. TCP options have things to reveal the operating system, and then the way that they actually deal with fragmentation obviously also differs. Along with this, an intruder, if they can sniff the packets, then it's possible for them to examine things like the TTL value, which differs, the window size, the don't fragment option, and the type of service. So these are done passively without actually sending any information to the server, where these are done actively. So just to give you a few examples, here are some of the tests that Nmap does to fingerprint the operating system. So it can send in a SYN packet with various options set, and then it looks at the response that comes back. So in this case, this is the response that comes back from a Windows machine for these tests. Xprobe gives us this facility, along with Win fingerprinting, which gives us a GUI for the fingerprinting. But the tool we'll often use is Nmap. So Nmap-O gives us a scan of our device. So we can see here in this case it's found out that we're using a Linux 2.6 device, and there's the operating system, and so on. So we've discovered the operating system, so now we can go ahead and fingerprint the services that are running inside the machine. And so we often use telnet and then connecting on a certain port for this. So in this case we've issued a get index.html, press return twice, and then this is what is actually returned back. So we can see here's the page that we see as the user, but we also get the extra information which can then be used to fingerprint the operating system, the service, and so on. So here we have the timestamp from the server, which can be useful for certain information, and we also have the web server type. In this case it's Google Web Services. There are other things that we can look within there, but the telnet gives us a good opportunity to be able to send commands to our protocol. netcat is another alternative. We can use the -v in IP address and port, and it'll grab the return back from the service. This shows an example of FTP when we connect to it. We see here there's the banner that it shows when we connect telnet to the server, and then on port 21. So straight away we can tell it's Microsoft. We feed in an administrator username, password, and then log in, and the syst tells us it's Windows NT type system. Here are the commands that we can actually feed to the system. We're setting up a passive transfer, which opens up a TCP port on the server. So there is extra information in here in the protocols that we often don't see when we use graphical packages. So in the final part of the 7 stages, we can then go ahead and map the network as we see it in terms of the hosts, where things are, what services are running, how the whole thing actually fits together. So we can manually do it, so we can actually go ahead and create a document with all the IP addresses, services, and so on. But we can also use tools that are used to automap, such as CheOps, traceroute, and neotrace. So this will give us the infrastructure that's created from here. So Visual Trace gives us automatic geographical mapping of the infrastructure. Okay, so to summarize, here's the 7 steps from 1 through to 7. First part is our passive information gathering. Sam, Spade, Aaron, Ina, Whois, NSLOOKUP, and so on are used in our passive type collection. We determine the network range. Again, this can be passive through RIPE, AppNic, RNIN, and so on. And then we moved possibly to a more active mode, where we identify the machines using ping, traceroute, angry IP scanner, superscan, find the ports that are then open through nmap, amap, superscan. We can then fingerprint the operating system through nmap, wing fingerprint, O0F, xprobe2, and ethercap. On to fingerprinting the services through telnet, FTP, netcat, and so on. Then finally we can map the network through neotrace, traceroute, and CheOps. Okay, so that's provided as a basic introduction to Unit 3 through the 7-step process